All right, so we're gonna do a video now, just showing some sinusoidal sources in LT Spice. This is something that we haven't probably seen yet. It's pretty straightforward, just your standard voltage source that we've been using. Um, of course, if this is new to you and this is your first LT Spice video in my class, hopefully you go back and look at the EE220 LT Spice tutorials. But we're gonna go hit F2 on our keyboard and type VO, start typing in voltage source, and we're going to hit OK, and that's going to give us a voltage source here that we can put anywhere in our circuit. I'm not going to go at this slow pace. I'm going to assume that you've watched the previous tutorials, and if you haven't, then please fill yourself in on those. But now I hit F3, and I'm going to just build myself a little circuit here so that I can ground one side of this, and I can label the other side. I'll just call it VS1, okay? And we're going to create basically one sinusoid here, and then we're going to create another one right next to it, and we're going to look at the two of these signals as we vary the amplitude, the frequency, and the phase of these two signals so that we can kind of see what we saw in the slides, but we're going to see it in LT Spice instead. Okay, so in order to use the source as an as a sinusoidal source in LT Spice, we just go ahead and right click on it or two finger click on it if you're using a trackpad, and you see that there's this option called advanced. We're going to click on that, and then it gives us a whole bunch of different options for different types of sources that we can use. In 220, we use them as DC values, and we also use pulse sources for our first order circuits. Now we're going to move into sine sources here, which have their own set of values. And for the first one, we didn't even talk about DC offset in my sine wave parameters slide. But if we wanted to use a DC offset, basically all that is it's the value that my sinusoid is going to swing around, okay? So if I said that I had a 0 volt DC offset, which is what we're going to be using most of the time, basically just means that the value swings around 0, okay? So it'll swing up to some positive VP max, some down to some negative VP max, or whatever you want to call that value. But it will swing right around an average value of 0. So you can also think of this as the average value of your signal. For this, we'll just start with a value of 1 volt for the amplitude, and let's just do a frequency of 1 kilohertz because it's easy for me to make the transient simulation with the 1 kilohertz sine wave. And for now, let's just start with basically a similar source, but instead of a 1 volt amplitude, let's go ahead and use a 2 volt amplitude so we can see what that does to the signal. Okay, so we're going to go 2 volts, and we'll keep it at a kilohertz for now. And so let's go ahead and hit Spice. We're going to run a transient simulation, and I want to see 3 cycles here. So let's do 3 milliseconds because I'm using a 1 kilohertz signal, and my period here is 1 millisecond. So 3 milliseconds will give me exactly what I need to see 3 cycles. All right, so let's go ahead and hit run. There's my window, and let's take a look at VS1. And so there it is. I'll probably change the color to something that's easier to look at, something like that. And so if I add, actually, yeah, that's fine. I have VS1 here, and we can see that it's swinging from 0 to 1 and down to -1, and 1 complete cycle takes 1 millisecond, right? That's what I was just talking about. So right here at around 1 millisecond, you can even see up here in the top, it shows my position of the cursor. So when I get to 0 for the sine wave, you see that I'm at about 1 millisecond on the x-axis right there, or right around there, right? And so that's my reference signal. Let's take a look at my second signal here. What's the difference? Well, now we see VS2. I'll throw that one in red. That signal swings up to 2 and down to -2, right? So that's me varying the amplitude of my sine wave in LT Spice, just like we did in the slides previously. So that's what a variation in amplitude looks like. It's really just going into the source itself on the advanced settings and changing the amplitude, right? So now let's make this one the same amplitude, but let's change the frequency. Let's make it twice as fast. Let's go 2 kilohertz. What's that going to look like when I hit run? So it's the same height, but now instead of 1 cycle at the same rate as VS1, I'm getting 2 cycles in in the same time that I'm getting a single cycle in for my blue signal here, right? Same amplitude, right? 1 volt, but my frequency is twice as fast. So instead of seeing 3 cycles in 3 milliseconds, I'm seeing 6 full cycles in 3 milliseconds. Okay, and so that's my second parameter that I'm interested in looking at. How about the phase? Let's go inside here, and let's go put this back at 1 kilohertz. We'll leave these other two parameters, the time delay and the theta, as 0. I think that those are related. We're interested in the phase phi here in degrees. Let's just make it something like negative 30 degrees, which should shift my signal along to the right by 30 degrees. So let's go ahead and run it. And there you go. You can see that the peak is shifted by 30 degrees. Maybe you can't tell that it's shifted by 30 degrees, but if you were to actually zoom in here, you can plot some cursors. You can always put some cursors on the signal. And I can take one here. I'm basically trying to find the height here of this blue signal, and then the one on the red signal as well. And this cursor window will take the horizontal difference between my two cursors. So in this case, it's 82.8 microseconds. Okay, you can now convert this into a phase angle by scaling it by the period. So actually, I'll just do that in my calculator while I'm here. It's 82.8 times 10 to the minus 6. I'll divide that by 1 millisecond because that's my period, and I'll multiply by 360, and I get 29.8 degrees. So that's telling me that I have a 29.8 degree phase difference. Of course, I'm placing these cursors manually, so I'm not getting a perfect 30 degrees, but that's pretty close, right? And so that's how you can check the phase difference between your two signals. Okay, so just go ahead and zoom out here. So that's just me basically showing the different ways that we can manipulate our sine wave. We can change the amplitude, the phase, the frequency, and all that good stuff right here inside the advanced voltage source editor window. And that's pretty much all for this video. Just wanted to show you how to do that. And now we're going to start using sinusoidal sources in our homeworks when we do our verification. So you need to get used to using these in transient simulations. And with that, I'm going to go ahead and end this video, and we'll see you guys in the next one.